Hey grade 10s, so today we're going to be finishing up looking at Newton's second and third law. So we talked about the first law last class, um, about how an object at rest will stay at rest or an object in motion will stay in motion unless acted upon by an opposing force. So you looked at this example of inertia here. And to explain what happened here, so the brakes acted on the actual semi-truck. However, there was no force being applied directly to this chunk of rock or chunk of cement that was being carried. So this chunk of rock was traveling at 100 kilometers per hour, let's say. This semi slammed on their brakes. Nothing was acting, no force was acting directly on this rock, so it kept traveling at 100 kilometers per hour until it had a force act upon it, which ended up being this force of the uh, truck, or the what's it called? The front part of the truck, not the bed, or not the transporting part. Anyways, so this piece of metal here ended up being actually the force that would have been applied to slow down this cement block, but obviously it provided a little bit more force at the beginning before it was able to be stopped, and we had this kind of collision here. So again, the brakes acted only on the moving vehicle, not on the cargo that was in here. So this continued to travel at 100 kilometers per hour and until it was stopped by this force. So let's look at Newton's second law. Newton's second law is the acceleration of an object is directly proportional to the net force applied on it and inversely proportional to its mass. So what does that mean? That's very wordy, very confusing. It basically means that objects that have more mass will require more force to accelerate at the same rate. So it also means that if you apply the same force to two objects with different masses, the one with less mass will accelerate quicker. So let's look at this in a practical example. So if we think about a golf ball and a bowling ball, if I hit a golf ball with a golf club, the ball would accelerate quickly. However, if I hit a bowling ball that has much more mass than a golf ball, the bowling ball would not accelerate as quickly if I applied the same force. So if you're thinking about it, you're holding a golf club and you swing and you hit a golf ball. That golf ball goes flying, crazy acceleration. If you did the exact same thing, if you took that golf club, swung it the same way, exactly the same way, but hit a bowling ball instead, that bowling ball is not going to go very far and you might actually break your golf club. So this is what we mean that an object that has more mass would require more force to accelerate the same. So I would not be able to use my golf club. I'd have to use something else to be able to make that bowling ball travel with the same acceleration as a golf ball, right? We'd have to use some sort of crazy implement to get that bowling ball traveling at the same amount or same acceleration. We have way more force behind it. So we use this formula to calculate Newton's second law. So it's force is equal to mass times acceleration, or F equals ma. So instead of remembering this big complicated, the acceleration of an object is directly proportional, blah, 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 I typically just choose to remember this as force is equal to mass times acceleration. So F equals ma. And you're welcome to do that too. So let's just look at an example here. So a bowling ball has a mass of 5 kilograms and a golf ball has a mass of 0.04 kilograms. And I looked this up, these are actual numbers. So I want both objects to accelerate at 3 meters per second squared. What force do I need for each object? So let's look here. This is all squished together for some reason. So let's spread that out before we take a look. Okay, so we have a bowling ball. We're going to start with our bowling ball calculations. So we have force is equal to mass times acceleration. So I'm trying to calculate for force. Remember, you could use this equation and have to rearrange. So you could calculate for acceleration, you could calculate for mass. In this case, we're just going to look at a simple example of calculating for force. So we know that the mass of our bowling ball is 5 kilograms. So I write 5 kilograms here. And I want it to travel at 3 meters per second squared. So I put 3 in here. So that means I need a force of 15 newtons. Pause on the newtons. Let's look at our golf ball. Force is equal to mass, which I know is 0.045 kilograms, and I want it to accelerate at 3 meters per second squared. So I need a force of 0.135 newtons. So we can tell that our force for an object that has a greater mass is way bigger. This is a way bigger force. 15 is way bigger than 0.135 newtons. So you're wondering, what the heck's a newton? Well, newton is the term or what we measure force in. So that's just like how we have kilograms or meters per second. Right here should be 3 meters per second. Force is measured in newtons, named after our favorite physics man, Newton himself. Got a little bit greedy, named it after himself. So anyways, you can clearly see that with a bowling ball that weighs much more, if we want them to travel with the same acceleration, it needs way more force than the golf ball. Okay, so let's finish off by looking at Newton's third law. This is the law that I typically knew the most. So you might have heard of this one before. For every force, there's an equal and opposite reaction, or equal and opposite force. So that means for every force, that every force produced is produced by another force. There's no such thing as a single force. So basically for every action, there's an equal and opposite reaction. So we'll just take a look at walking as an example. So when you push your foot onto the ground and you take a step, the ground applies a force back to you which propels you forward, and this is why you move. So you apply your force backwards against the ground, and the ground applies a static frictional force forwards against you. So that's what actually causes you to move. Your force and then the force of the ground acting back upon you. So forces always happen in pairs. Nothing ever happens on its own. There's never just one force. So in this case, obviously the ground is applying a greater force to you than you are to it, because if one force is greater than the other, the one object will move. So in this case, the ground applied a greater force to you, which caused you to move forward. So I hope those 3 laws make sense. If you have any questions, let me know. But other than that, enjoy thinking about Newton's laws that they could apply to your own life.